Good morning to everyone. In today's video, we are going to see the lossless or low loss characterization. Here, only one concept we are studying, that is lossless. So, in the name itself, it is suggesting that lossless. That means there will not be any loss in your transmission line. So, basically, in your transmission line system, we are consisting of four parameters: R, L, C, and G. So each component will corresponds to their specific working. So among all these things, R will gives the whatever the series losses are there, whatever the series I square or losses, and transconductance G will provides the what will be the shunt losses. If the transmission line is said to be a lossless, then the components corresponding to this loss will be equals to 0. So the same thing is we are going to say. So for example, if a transmission line is said to be lossless, if G and R, that means the series loss component and the shunt loss component will be very less. For ideal cases, it will be equals to 0. So R is nothing but your resistance per unit length, and G is nothing but your conductance per unit length. Whenever you are assuming this resistance and conductance will be equals to 0, the transmission line is said to be a perfect conductor or perfect dielectric. So if I mention that R equals to 0, that means the resistance component equals to 0, the conductor seems to be a perfect conductor because the I square or losses will be equals to 0. When G will be equals to 0, then whatever the dielectric losses are equals to 0, then it will act as perfect dielectric medium. So as we know that characteristic impedance Z0 equals to square root of R plus J omega L divided by G plus J omega C. So when I replace this condition, R equals to 0 and G equals to 0, then the characteristic impedance will become as square root over L by C. The same thing will follow for your propagation constant. So when R equals to 0 and G equals to 0 places in your propagation constant, the propagation constant will be in form of J omega root over LC. So we simply replace this value. So the rest of the elements we just take out. So the propagation constant will nothing but the summation of your attenuation constant and phase constant. So from this propagation constant, the real value equals to 0. So whatever the attenuation constant alpha equals to 0 and propagation constant phase constant beta equals to omega root over LC. So from this we can give a summary of your lossless transmission line, which is having the characteristic impedance Z0 equals to root over L by C and propagation constant equals to J omega root over LC and attenuation constant equals to 0 nefs per meter and phase constant equals to omega root over LC radians per meter. That's it. Thanks for